Hi, and welcome to another Hopper on 6502 video. I said I might do a blink example just for fun. Well, here we go. Kind of a good idea to show off what's special about the Hopper runtime on a 6502. So we've got our breadboard again. This is a sort of a very similar to what you would do on an Arduino, pin mode, digital write. So I quickly, if I right click on things, I navigate to them like that. Implemented GPIO pins, conveniently numbered them 0 to 15, and then it sets the direction register in this 6522, the VIA, based on whether you want to read or write direction. And then port A and port B, it'll translate the pin to which bit in that port must be set. Anyway, let's build it with F7. And then we'll F5 to run. Takes a little while to upload this to the device. There we go. It's successfully uploaded it. When the title bar changes from blue to green in the IDE, that means we're now in the debugger. So if I press F5, it'll run. And there we go. We've got our blinking happening. So every half a second, it's switching between the 0 and 8. So the 0th pin in either of the ports. Now, if I press Control C here, I break, and the stack here on the right. Let me see if I can get the stack a bit more visible there, like that. Yeah. So the stack shows us we're in the main method. But we can now single step in, so we can F11 to step in. All the shortcuts are always on the menus here, and they're Visual Studio shortcuts. So here we can see we've stepped into digital write, and our arguments are the pin, which is 0, and to set it to false. So we're in the process of switching that blue LED off. So it if the pin is less than or equal to 7, then it's going to choose port A. So let's see what happens if I step there. So the port is hex F1, and the ports are actually counterintuitively they're the wrong way around. So if I right click on port A here, hex F1 is port A and F0 is port B. So, and then Control backspace to go back to where I was. Okay, so it's going to AND my pin with that, which is going to give me a 0 because this is pin 0. There we go. It's going to shift 1 left by 0, which is going to give me a 1. So now my pin, if you look in the, it's an argument, so it's still in this part of the stack here, is now set to 1. It's going to go get the current value of the entire port, of all of port A, and the current value of port A is the 1 because the little blue light's on. And then the value that I'm setting, the Boolean, I'm setting it to false, so it should go into the second case here. If I step here, F11, yes, and now it's going to AND it with the inverse of that pin, so it should wipe it out, set it all to 0. There we go. And now when I write, because the IO is memory mapped on the 6502, I'm actually writing to the memory address of the port. It's on the 0 page, and as I do that, that LED should go out. There you go. And we go back, and here we are debugging. So the minimal runtime, this virtual machine that I'm running, that I'm connecting to make the debugger work, it fits into 8K. Even though I have 32K ROM, I'm only using 8K of it. And in the minimal runtime, I implemented strings as a reference type and arrays as a reference type, and then the value types are the usual ones: bytes, chars, ints, and uints. So on my previous iteration last year, I also implemented longs as a value type, as a reference type, because they're bigger than the stack slot, so they've got to be a reference type. And I implemented dictionaries and lists, but I haven't done that this time around when I re-implemented this using my own 6502 assembler. And I might do it, but I think I'm going to focus on the hardware for now. You can write pretty decent programs with just strings and arrays for now. And it's really nice to sort of just be able to single step and debug in a sort of C-like language here, a little bit more C#-like because it manages the memory for you. And in your system, if you right click on system here, you can see These are the classes available to you with different functions that you can use that's built in. Yeah. Anyway, it's supposed to be short and sweet. So let me just let it off the hook. I'll press F5 and keep running. Oh, I mean, I could show one more thing. I could put a breakpoint here, for example, F9 for a breakpoint, and then it should run until that breakpoint. There we go. It's stuck on the breakpoint. When it turned gray, it arrived here. And if I press F5, it'll go through each of the lights. You know, it'll do one more and get to the breakpoint again, and then back to the breakpoint again. Every time I press the key, and I'll get to the breakpoint. Yeah. So you can do breakpoints. You can single step. Yeah, you've got a watch window. You can see the variable values. It's a pretty nice debugger to have connected to a breadboard computer. I mean, this is probably a better debugger than you have most of the time with Arduino devices. Anyhow, thanks for watching. If you're interested in all this, there's a playlist connected to you here, which is about my 6502 toolchain that I've just built for the Hopper environment. You might as well watch that. Cheers.